So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you for the confirmation, everyone. So my name is Neeraj Kheria, and I have been working in this IT industry for more than 13 years now. So today we have gathered to discuss on the concept of object-oriented programming, what exactly object-oriented programming is, how OOPS compares itself to the procedural programming that we have. And then we are going to discuss on the OOPS concept, that is inheritance, polymorphism, abstraction, and encapsulation. So these all are the part of focus for today's session that we are going to discuss on Java. So object-oriented programming is a programming style which is basically associated with the concepts like class, objects, inheritance, encapsulation, abstraction, polymorphism, as etc. And the most popular programming languages are like we have C, C++, Ruby, and they all follow the same concept of object-oriented programming paradigm. So object-oriented programming refers to a type of programming in which programmers define the type of the data structure and the type of operations that can be applied to a data structure. So as Java being the most we can say most on-demand skill set, we will be talking about about the object-oriented programming concepts in Java. And an object-based application in Java is based on declaring classes, creating objects from them, and interacting between these objects. So that's the point of focus for our today's session as well, on how the entire objects are defined in class and then how we can define the class and we can define them. So for example, here we had defined a simple class. Now the class is dogs. Now there are multiple breeds of dogs, correct? So again, we have defined the input. Again, they all have some common behavior, correct? Like they all walk on four toes, and when they all have tails, they all have almost some of the common features across all breeds. So the properties for dogs will be breed, size, age, color, and in terms of the behavior, it is going to be eating, sleeping, running, and barking. So these all are going to be a common behavior for each and every of these classes. Now, in terms of the OOPS concept here, so for different values of data members, there's a breed, size, age, and color. In Java class, we will be getting a different dog object. Like we have a properties, breed, size, age, and color, and then they all be having different properties, as in different behavior for eating, different behavior for sleeping, running, and barking, right? So the same property is going to be applicable for each and every of the class objects, and they all can have different behaviors as per the concept defined here, right? They may have same properties, but their values are going to be absolutely different. All right. So if we compare OOPS with the procedural programming, now basically we have two things. We have the object-oriented programming, and then we have the procedural programming. So there are multiple differences here in object-oriented and the procedural. So first of all, object-oriented follows the bottoms-up approach. Then it is whereas the procedural follows the top-down approach in terms of designing the entire template accordingly. And then in object-oriented programming, it is divided into multiple individual objects. And again, it is divided into objects for object-oriented, whereas for procedural, it is divided into functions. In terms of object-oriented, it has access modifiers, whereas in procedural programming, it doesn't have any kind of access modifiers. Whereas for in object-oriented programming, objects can move and communicate with each other through the member functions. Whereas in terms of procedural programming, data can move freely from function to function within the entire system altogether. All right. And then in terms of object-oriented programming, it is much more secure because each and every functionality is divided into multiple objects, and then we can have a complete control on the object access type as well. Whereas in procedural programming, it is less secure because again, here each and every object is not divided into objects. And then that's why the object-oriented programming, the OOPS supports the overloading method, whereas for procedural, it does not support the overloading method. Now, in terms of the OOPS concept, now, as we discussed, OOPS has four main components. First of all, we have inheritance, encapsulation, abstraction, and polymorphism. So first of all, let's talk about the inheritance part. So now we have seen that what are the main benefits of object-oriented programming. We get improved productivity through software development cycle. We get improvised software maintainability. We can have a faster development sprint as compared to the other platforms, and it can also have a higher cost of development. We can simply reduce the cost of development as compared to going for procedural programming, and then we can get a higher quality software by following the OOPS concept. There are also some of the common challenges as well. So whereas again in here we can have a steep, we are going to have a steep learning curve. We should be having a larger program size, and they should be having a slower program execution, and it's not a one size fits all against a solution. You always have to customize the solution as per the requirement. So first of all, if you talk about inheritance, then inheritance is the property of an object to acquire all the properties and behavior of its parent objects. And inheritance represents is a relationship which is also part of the parent-child relationship that we have. Same way we had talked about animals. So now when we talk about animal can be a one class, and then the mammals can be mammals, reptiles, amphibians, birds. They all are deriving some common properties from the animal class. Although they all are different, but again, they all derive some common properties from the animal class itself. Correct? So that's why inheritance is a concept where the properties of one class can be inherited by the other, and it helps to reuse the code and establish a relationship between these different classes. And inheritance are basically contains two different properties. We have the parent class. That means that here the animal is a parent class, whereas the mammal is the child class that we have. All right, and then in terms of syntax, so first of all, if you want to declare any parent class here, then we can define the class as the name itself. But first of all, we have to name the subclass, and then we have to define it extends the superclass itself as the entire as a syntax that we can follow for defining the classes. And the main advantage of classes, it can simply allow us to reuse the code at any point of time, and it also is extensible. It allows us to override, and it also allows us to hide the data as per the requirement. Now, inheritance are basically mainly of three different types here. We have single, we have multi-level, and then we have hierarchical. We also have something called as hybrid that we are going to discuss. So first of all, if we talk about single inheritance, in single inheritance, one class inherits the properties of the other. So here we have one parent class, and then we have one child class. So basically, class B is going to inherit all the properties from class A, and this is called as a single inheritance. That means there's only a single subclass from the parent class that is going to inherit all the properties from the parent class itself. That's the main part of using the inheritance. So for example, if you want to create these classes here, then we can make use of any of the IDs. Now, when we talk about IDs, we can make use of Eclipse, we can use IntelliJ, or we can use any of the other IDs as Visual Studio, depending upon the comfort level or whichever platform is available for us. So in case you want to work with IntelliJ, the IntelliJ also offers a community version, as in if you want to use the IntelliJ platform just for the learning purpose, then we can make use of the IntelliJ IDEA community version, where we can get the entire JVM and Android development environment that we can use for free. Whereas if we are going for the entire web and enterprise development, then we can go for the ultimate as in paid version. So it all depends upon your comfort level. We can use IntelliJ, we can use Eclipse as well, depending upon which platform we are having the license and we are comfortable with. We can also use Eclipse. If we are comfortable with Visual Studio Code, and here we can use Visuals, and here we can use the Visual Studio as well. Visual Studio, not the code, because code again is basically used mainly for the entire scripting task here. But again, if you want to define the entire, if you want to use it as a code editor, then we can use it as code editor, or we can use the Visual Studio 17 as a part of the ID that we want to make use of for our code development. So now we can make use of any of the editors that we want to work with. For example, here we are going to use the IntelliJ core editors, right? So here we can use IntelliJ IDEA. Here we can start a new project. click on create new project. We can choose which all platform we want to use for building. Again, in case we do have the requirement, we can click on next. And let's suppose here we name the project as Edureka. Let's create this. So here we have the entire ID open. Now here we can see the entire project structure that we have created. Now we want to start with any of the file here. Then here we have the file. Suppose here we want to start with a new class. So here we can simply right click. We can define a class. Let's say we name the class as Edureka itself. So here we can define a class name as Edureka. So a public class by the name of Edureka has been created. Okay, let's do one thing. Let's increase the font size so that we don't have to strain our eyes. Let's increase the font size of the editor. Here you go. So I've increased the font size here so that you can have a better clarity on whatever we are going to create here. If you want, we can increase the size further. All right. So now we have defined a public class as Edureka. Now, if you want to go for the inheritance part, suppose if you want to inherit this as a single level, then here if you are creating multiple other classes, for example, here we can define another class as, now from Edureka, we can define another class as web. For example, here we can define class web extends. Now, if you want to import, you want to simply extend the class here, then we have simply define class name and then which one is going to inherit which class. So as you can see here we define class as web, and then class web is going to extend the property defined under Edureka class. So whatever we are going to define under this class, that's going to be applicable, or that's going to be inherited by the web class as well. So basically, this is how we take care of the single inheritance that we have declared, that we have available in Java OOPS concept. Now, same way, we also have the concept of multi-level inheritance that we can make use of depending upon what kind of requirement we do have. For example, now in terms of single inheritance, suppose if you want to see an example, let's do one thing. Let's create another class as well. Let's create another class. Suppose, let's say we create the class for car. So currently we have a class defined for car, and now we want to inherit some properties out of it. We want to inherit some properties out of it. So what we can do now, we may define the properties for a brake for a car itself. For example, here we can have one protected string defined here. We can define protected string defined as a brand. For example, suppose here we define a product string as brand. So brand can be any string that we are going to define here. Suppose here we are going to define the brand for BMW. This can be any product string. And then we can define public void. Suppose here we are going to get the property for a complete horn. So here we can define honk as a horn, or we can say this can be honk, this can be brake as well, whatever we want to define as a part of the property. So here we can define honk, and here we can define the property as in system.out.println, and here we can define what kind of honk we have. Suppose here we define as beep, and then currently we define the entire property as beep, and again here we define the property as beep beep. So again, this can be any particular, or we can say, class that we are going to define here as a part of the property. So we are going to keep this entirely as a part of the class itself, right? Now we can create another class. So here we can define class as, suppose here we can define the class as car1, and now here we can define the class car1 to be to extend, suppose or suppose we have a property defined here for some other car or some other brand. Suppose here we have car class defined as Audi as well, and here we can extend this to car class that we have created. Now in here we can define the properties for class. So here we can use a private string. We can define a property as private, and here we can define a model name. So we can define model name. Now this can be model name as, suppose, A7 or suppose A8. Here we can define A7, and then we can define the public static void main, and here we can define the entire string property here. Now under string we can define the string argus, and then we can declare the car. Now here we are going to use the same property defined in the main class. So here we can define car, and suppose here we define car property as my car. So here we can create a new object for car. And now after this new object creation here, we can define my car dot honk, as this has been, now we haven't defined the honk here. We had honk has been defined earlier in the main class, in the parent class. So here we can define my car honk, and then we can simply use the message as system dot out dot println, and then we can define from my car. Now my car, in terms of the property that we defined here, my car, and whatever property we defined here, suppose earlier we defined the property for brand, so you can define brand, and then we are going to display the property here, suppose here for the property plus my car dot model that we have defined, as in model name that we define here for the car that we define. Suppose here if we define the as Audi, so here we can define A7 as the property. Suppose here the brand name is going to be copied from now the model name is going to be copied from the from this class, and the brand is for car is going to be copied from here. So that's how we can define the entire model name, and this is going to be executed accordingly. So basically we have defined one property, one object here from the in the parent class, and in here we are importing that in the child class itself as a part of the inheritance. Now next, we are going to discuss on the entire concept for multi-level inheritance as well. So same way we have discussed, we have a single level inheritance. Same way we can go for multi-level as well. So in multi-level, we have multiple classes inheriting from each other. Like for example, class B will be depending upon class A. Suppose class B is going to extend class A, and class C is going to extend class B. So whatever has been derived by class B from A is also going to be inherited by class C from class B itself. All right. And then we have hierarchical. So hierarchical as in if we have multiple classes inheriting from a single class, then that is what is referred as a hierarchical concept altogether. And polymorphism is a property of an object which allows it to take multiple forms. So the type of polymorphism in Java, it is having the compile time and the runtime required here. So basically, if we talk about the polymorphism concept, then polymorphism simply means making multiple forms, where poly means many and morph means forms itself. So it basically allows the variable, function, or the objects to take on multiple forms. So in other words, polymorphism allows you to define one interface or the method and have multiple implementation done. So basically, just by taking a real life example, we can understand the entire concept. Let's say we are working with in the field of cricket, and we know that there are multiple types of bowlers that can be fast bowlers, they can be medium pace bowlers, and they can be spinners. Now, as we can see, so bowler class, now there will be a single class such as bowler class, right? There will be a single class as bowler, and then they can have multiple different categories. It can have three child classes. We can have fast bowlers, we can have medium pacers, and then we can have spin bowlers. We can have spin bowlers. Now, bowler class is going to have a simple bowling method. Suppose here we have a bowling method defined. So bowling method is going to be used by every of these child class itself, right? But the entire implementation of bowling method is going to be different, because again they all are having their different bowling speed. The way of bowling is different, correct? So the way the bowling method is going to be implemented is going to be different for fast pacers, and it's going to be different for the one time for the pace bowlers or for the spinners as well, right? So basically that's why that exactly is what happens in the polymorphism. So all three classes are above inherited as the bowling method, but the entire implementation method is totally different from one another, and that exactly is what we mean by polymorphism. And even in polymorphism, there are two different types. We have the compile time, and then we have runtime polymorphism. Now, runtime polymorphism refers to a process in which a call to an overridden method is resolved at the runtime altogether. Let's erase this up first. And now in this, a reference variable is used to call an overridden method of a superclass at runtime. And method overriding is an example of runtime polymorphism. So basically, if you want to see again how now these are the rules for overloading in compile time. Overloaded methods must have a different argument list. It can have different return types if argument list is different, and can throw different exceptions, and can also have different access modifiers when and if and when required. All right, so next we have the concept of runtime. So this is what we have discussed for compile time, and then we have runtime. So runtime polymorphism refers to process in which the entire overridden method is resolved at runtime rather than having a compile time polymorphism defined here. And in compile time, we had seen the number of parameters passed to a method is basically, again, the arguments can be different based on parameters passed, based on data type of parameters, and sequence of data types when passed to a method. Whereas in runtime, it is basically or works on the method overriding of runtime polymorphism. Now, for example, if you want to see a simple example of how the method overloading works for compile time, let's come back to our code. So let's say here we create another class here. Suppose here we define another class, let's name it as adder. So now here we can define something. Now here we can define a static component. So here we can define static and static integer that we are going to add. And in here we can define integer A and integer B. Here we can return A plus B, and then we can define static double value. Here we can define static double add, where we are going to declare double A and double B. And after double A double B, then we are going to again define a class where we are going to return A plus B. We're going to return A plus B. Now in here we can, okay, I think we haven't closed the previous tab here. Now here define the static return A plus B, and now we can use statement for public static void main. So here we can define public static void main string argus. Now in here we can define the entire parameter, such as now here we can print the statement system.out.println, and here from the adder component we are going to add the property. Suppose here we can define the entire matrices. Suppose we want to print 13 and 15. We can define the parameters here as a value for A and B. And same way here we can define the parameters. Now currently we define the adder component here. Let's close the value for adder. And now we can print another value for the double value as in system dot out dot println. And here we can define adder dot add. And here for the second part, we can define any double value. For example, let's say here we can define 11.9, and then we can define 8.4. This can be any value for A and B in terms of double value that we are going to define here. So basically in here we define the entire public class as the adder, and then here we define the static integer where we're going to declare first of all the integer and then the entire double value, all as a part of understanding of how method overloading works. So now we are going to discuss on the concept for encapsulation. So encapsulation is basically a mechanism through which we can bind our data and code together as a single unit. It simply means that we can hide our data in order to make it safe from any further modification. And what exactly this means that the best way to understand encapsulation is to look at the example for a medical capsule. So when we talk about the entire medical capsule, again, we know that the entire methods itself is the outer covering, and all the variables that are going to be declared that itself is present without, we can say within the covering itself, correct? So the drug is always safe inside the entire capsule, and the entire outer layering is the one which is going to protect it, correct? Similarly, through encapsulation, the methods and variables of the class are well hidden in a complete capsule itself, and it is safe. And we can achieve encapsulation in Java by declaring the variables of a class as private, and we can also do that by providing a public setter and getter method to modify and view the variable values. For example, A simple use case, we can come back to our ID and suppose here we create a new Java class by the name of employees. Let's say here we create a new Java class by the name of employees here. Now, once we are working with the employee class, now here in terms of employee, we can define a private. Here we can define the private. We can create a private string by the name or suppose simple as name. And then we can define a public string. Here we can define public string get name. And in this public string get name, we can define, now here we can simply return name. Here we can return name. Now, since we define name in smaller case, we can keep this in smaller case itself. So here basically we are going to return name, and then we can create another public void main. Not suppose let's not declare this as a main method. Here we can define this as set name, and then we can define the string value for name that we define. In here we can define this dot name is equals to name. Let's declare we have declared this inside this variable itself. And then we are going to create another public static void main string argus. So basically here we are now what we had done here we have made a particular component defined. We had defined the entire class as a string as private for storing it, and here we define the entire private string name, and then we define a public string. Here we define the entire public string as get name, and then we are going to return the name itself from that particular class which has been defined. So basically here what we have done here, we defined the entire class name. Here we have simply made this entire parameter as private itself to what we have currently defined. Now another method we can make use of, now basically here we can try to instand the above code as we done. So we have defined a class as employees which has a private variable defined as name. And then here what we had done here, we have created a getter and a setter method through which we can get and set the name of the employee. And through these methods, any class which is going to access the name variable has to do it by using these getter and setter method that we had defined right now. All right, as a part of encapsulation. And same way as encapsulation, we also have something called as abstraction. So basically an abstraction is the quality, it simply refers to quality of dealing with the ideas rather than events. So it basically deals with hiding the details and showing the essential things to the user. A simple use case, when we boot up any system, when we turn on our phones, our laptops, our systems, we get to see the windows or the logo of the company when it boots up. So again, that is simply a way of hiding all the background process which is currently running, correct? And that exactly is what we mean by abstractions. So we don't know the internal processing of how the entire system is booted up when we boot up, because again, we get to see only the logo being shown to us, whereas in the background, multiple processing is being done. So that's why abstraction helps us to reduce the complexity, and we can achieve abstraction basically by two different methods. We have abstract class and then we have interface. So abstract class in Java contains the abstract keyword. Now, what does the abstract keyword means? If a class is declared abstract, it cannot be instantiated, which means we cannot create an object of an abstract class. Also, an abstract class can contain the abstract as well as the concrete methods. So to use an abstract class, we have to inherit it from another class where we have to provide implementations for the abstract methods there itself. Else it will also become an abstract, or we can say an abstract class itself. So basically now we can define the class as abstract by adding the abstract symbol altogether. As abstract class mobile and abstract void main. And then we have the interface itself. As we discussed, abstract can have both abstract and non-abstract methods. It cannot be instantiated and can have constructors and static methods both defined. Whereas if we talk about interface, so interface in Java is basically a blueprint of a class, or we can say it is a collection of abstract methods and static constants. And in interface, each method is public and abstract, but it does not contain any constructor. So along with this abstraction, interface also help us in achieving multiple inheritance in Java. So now we should note that we can achieve 100% abstraction using the interfaces. So an interface is basically going to be a group of related methods within empty bodies. So we can take, if you are working with any of the parent class here, then we can define the parent class, which is going to be inherited from any child class. And then the class is going to implement the interface for getting 100% abstraction. And the encapsulation is something that we have discussed already. Thank you so much for joining and have a great day ahead. Take care. Bye-bye.